Hello, my name is Kevin, and my project is based around the relationship between distance and angular velocity throughout our solar system. More specifically, how the distance between planetary objects and our sun affects orbital angular velocity of planets. This is my demonstration. It is made out of water bottles, cable ties, a hula hoop, and elastic fabric, and also paper clips too. We'll be using this in order to visualize gravity in an interesting way, and just be placing objects on there. We'll first put down our planets first on the tarp. These little marbles will be our planets. So if I put this down, you can see that there's little to no bend within the fabric. However, if I switch this out for, let's say, our sun or a heavier object, you can see that it bends way more significantly than our little planet. And how does this visualize gravity? Well, as you can see, if I were to place this down again, we can somewhat orbit this planet around the sun. And another thing that you can visualize with this demonstration is how orbital angular velocity changes within an orbit of a planet. So how does this demonstrate changes in our angular velocity? Well, as you can see, whenever I throw this marble, you can see that during its cresting period at the top, it'll begin its slow velocity state. And whenever it starts to go towards the sun again, it'll start to speed up. And then when it goes right back up the fabric, it'll start slowing down, and then it'll keep repeating until it eventually hits the sun. We can also tie this back to our solar system, which has planets that orbit within an oval shape, which means it'll have periods of its orbit whenever it's closer to the sun and farther away from the sun. So for one final demonstration, I'll throw another marble, and you can pay attention to how the angular velocity changes as it hits the peak and goes past the sun.